Hello students. So we were discussing in the last video, um, that is video number 9, about lengthened contraction. Now let's discuss further on this topic, what is lengthened contraction. Okay, so how will you define this lengthened contraction? Okay, so if you see the definition here also you can do NIDE, lengthened contraction. Okay, similarly here actinide contraction. So how will you define this lengthened contraction? So lengthened contraction is the lengthened contraction is the greater than expected decrease. Lengthened contraction is the greater than expected decrease. Lengthened contraction is the greater than expected decrease in ionic radii of the elements let me make it of the ionic radii of the elements in the lengthened series from atomic number 57, that is lanthanum, to atomic number 71, that is lutetium. Atom number 57 lanthanum to atom number 71 lutetium, which results in smaller than expected ionic radii for the subsequent elements starting with atomic number 72, that is hafnium. So we can say that the size of the element starting from hafnium, that is, now here hafnium is again from D block, lanthanum is from D block, and between lanthanum to hafnium, it means 58 to 71, they are the member of F block, and due to appearance of them, the size of the subsequent elements, that is decreased, and this is called lanthanide contraction. Now if you see the impact of this lanthanide contraction is here, there is no remarkable change in the atomic size of 5D series after 4D series. Okay. To elaborate it further, I will give you example. Here it is lanthanum. Now the electronic configuration of lanthanum is note 3, 5D1 6S2, and that of hafnium is 5D2 6S2. Now in between lanthanum to hafnium, what happens? There is a number of 14 elements which has been shown here outside the table. They lying from cerium 2, that is 58, to lutetium, that is 71. Now there the 4F subcell is progressively filled. Now 4F subcell is also having very poor shielding, and because of that, what happens? Because of this, the valence shell from the nucleus is not repelled as much as it would have been in the case of S block elements and P block elements. Now this you can say valence shell, NS electron, they are expected to be here, otherwise in S and P block. But now there are 14 electrons are filled in 4F subcell. Meanwhile 14 proton will also be put there in the nucleus, so nucleus becomes stronger and stronger. But what happens, this F subcell does not repel the outermost cell as it do in the shielding effect or screening effect. So the screening or shielding is not done properly. Because of that, the expected size, this is the expected size, and this is the actual size of whom these hafnium onwards, these elements, their expected size is not as increased. This happens only because of these lanthanides. That's why it is called lanthanide contraction. Okay. Similarly here, if you see between actinium and RF, you will see there are 14 members of actinoid series, and again there 5F will be fully filled, and because of that, due to the poor shielding of these, the expected size of RF onward up to CN will not be as increased as it is expected, and this is, it will be called as actinide contraction. Now impact of this you have seen in this diagram. The size is not increased as would have been. That's why 5D and 6D, they are almost superimposed, their curve, they are almost superimposed over each other. So this is lanthanide and actinide contraction. I hope you will understand. We'll see you in the next video with further new topic.